we are beginning today our introduction to matrices, and all a matrix is some rectangular array of numbers. So here are a couple examples. And what we will look at with these is, first of all, something called a dimension. We'll be using this term a lot. Dimension is just how many rows and columns there are. So in this one we have 3 rows, 2 columns. This is called a 3 by 2 matrix. Usually we denote the rows by m and the columns by n. So 3 by 2, this one down here is a 2 by 3 matrix here. And what also we can look at here is these things in the matrix. Each entry is called an element. I'll call them entries, I'll call them elements. We use that interchangeably. And the last thing we'll deal with down the road is called square matrices. And square matrix just means m and n are the same number. It literally looks like a square. So that's a 2 by 2 square matrix. And square matrices down the road will be very important for us in terms of finding various things called determinants or row reduction, solving like that. We'll be talking a lot with that. So a couple things we can do with matrices. Matrices are denoted with capital letters. So a capital letter A, for example, denotes a matrix. And we name the elements within the matrix with the lowercase letters. So, for example, if they give us this one right here, which is A12, is how we would say that, A12. That means we want to look at, in matrix A, what is the item in the first row, second column. Well, here's the first row, here's the second column. So that entry, or that element, is -2. Similarly, 2, 1, so second row, first column, that entry right there is 0. And A33, those ones on the diagonal are easy to understand. Third row, third column, that entry is just 4. So those are different ways that we can look at what a matrix is and some of the elements within them. Now, how to construct a matrix. What we've done in the past and what we'll use matrices a lot for is for solving equations. For example, if we had this equation here in green, what we probably would have done was gotten x by itself, 3 minus 2y. And once we got x by itself, we could kind of plug it into the other equation, solve for one variable, then plug back in, solve for another. It always worked, but it was very tedious. And what happened if we had something like this, where we had 4 different equations going on? Well, what we can do is we can turn this into a giant matrix, and this is how. If I make a big matrix like this, each equation essentially will have its own row, and each variable will have its own column in the row. So I'll have a column for the w's, the x's, the y's, and the z's. And I'll also have a column for the what each of those equations equals. So I'll just give it a little question mark, because it really isn't a number. I guess it's a number, it's really not a variable, I guess is the better way to say it. So the entries within this matrix, the elements, well, all I would do is I'm turning it into an array of numbers. So what I'm going to do is whatever the coefficient is, I'm literally just going to write that coefficient. So the coefficient for w here was 1. For x was 3. For y was -2. For the z was 4. And then my number on the end by itself was 10. I can do the same for each of these. 3, -2, 1. There is no z, so my z coefficient is 0, and the number on the end was 2. In this one, I have a -1 in front of w, a 7 for x, -3, 1 for z, and a 0. And then for this last one, there's no w, there's no x, there's 1 y, there's 1 z, and the number on the end is 3. Now, what ends up happening, this just looks a lot neater, it's a lot easier way to look at it, and what really is cool is we'll learn down the road a way to, it's called row reducing, and we'll be able to, where it would take probably 20 minutes to solve a system like that, it would take maybe only 2 minutes to solve a system like this, but we'll get there well down the road. So there's your brief introduction to matrices, and soon we'll start with the matrix algebra that goes with it.